Right, this is lesson 5, solving equations and inequalities by graphing. Our essential question is, how can you solve an equation or inequality by graphing? Okay. Table of contents. Use a graph to solve an equation. All right, so example, how can you use a graph to solve an equation? An equation is a statement that has two expressions that are equal to one another. You can graph each of the expressions, and where they overlap is your solution. So if I wanted to solve negative 3x plus 20 equals 5 by graphing, I'm going to graph the equation that's on the left, or the expression that's on the left. So negative 3x plus 20. And then I'm going to graph the equation or the expression that's on the right, 5. Okay. Then I'm going to see where these 2 points overlap. In this case, they overlap at x equals 5. So I'm going to use a graph to solve the absolute value of x minus 4 equals 1/2 x plus 1. So again, I graph my left side, and then I graph my right side. And in this case, they're overlapping at 2 different points. So I have 2 solutions, one at 2 and one at 10. Okay. Solve a one variable inequality by graphing. So if I wanted to solve x squared minus 4 is greater than 0, okay? I want to graph the expression on the left side of the equation, the x squared minus 4, which looks like this graph here, okay? And then I'm looking for places where the graphs are greater than 0. So in this case, I'm looking at things that are above the x-axis. So it's positive from the interval on the left of negative infinity to -2. That's the point where it crosses the x-axis. And then again from 2 to infinity. So your x-intercepts, the places that they cross the x-axis, those are important, especially when you're talking about inequalities. Okay, so x squared minus 4 is greater than 0 when x is less than -2 or x is greater than 2. So a motorcycle is 40 miles ahead of a car. The motorcycle travels at an average rate of 40 miles per hour. The car travels at a rate of 60 miles per hour. When will the car be ahead of the motorcycle? So I'm going to let x equal the number of hours since the vehicles started traveling. Okay. We know the car is traveling 60 miles an hour. So 60 times however many hours it's traveling. So 60x. The motorcycle is traveling 40 miles per hour. So the distance the motorcycle travels in x hours is 40x. Okay. I want to know when the car will be ahead of the motorcycle. So I want to graph the two expressions, 40x plus 40. Okay, and I'm graphing that expression as 40x plus 40 because the motorcycle was 40 miles ahead of the car. Okay, and then I'm going to graph 60x. In this case, they overlap at the point 220. Okay, so that means at 2 hours, both the motorcycle and the car will be at 120 miles. Since I'm trying to figure out how far they've traveled, right? At the point 120, the car and the motorcycle are at the same spot. So anything past 2 hours, the car should be ahead of the motorcycle. Use the table to solve an equation. So not every time that you put graphs into, if you actually graph them, equations into graphs, they're going to have exact solutions. Sometimes they will have decimal solutions or fractional solutions, and sometimes they'll have repeating solutions, or you're trying to get as close to that possible solution as possible. So in this case, if I have x squared minus 4x plus 1 and x minus 2, okay, I graphed both of those. I graphed the right side of my equation and the left side of my equation. And I can see that these graphs or these points where they connect or overlap are not anywhere close to an actual whole number. Okay. But with this, and I graph these via Desmos. So if you graph them with Desmos, which is technically graphing technology, you can just click on the points and they'll give you those points. But if you're using a graphing calculator, you may need to look at a table. Okay. Or you may actually be able to plug numbers in. Okay. In this case, we used a table. Okay. I can get tables by substituting values into X that are closer and closer to the points. So you're looking for the two equations to be equal or as close to being equal as possible. So in this case, I'm looking at 0.6 and 0.7. They're pretty close together. Okay. So I'm going to break that down. So I know my number is between 0.6 and 0.7. Okay. So now I broke it down to 0.65. I took it out a decimal place further. And I noticed that between 0.69 and 0.7, they're closer still. So I took it out to another decimal place. Okay. And noticed that 0.697 and 0.698 are again the closest. Okay. So you find that one of your solutions is approximately 0.697. Okay. You can also do this for the other solution. So if you looked at it, this was at 2 different points. Okay, so you can use this exact same method to find the other solution as well. Using graphing technology to solve equations. So the nice thing is if you're using a graphing calculator or if you're using Desmos, both of these really allow you to pinpoint where your solutions are. Okay. If you're using a graphing calculator, you'll use what's called the trace function. Usually in our class, we'll be using Desmos, and Desmos, you click on the point and it gives you this point 2.69722, comma 1.30278. Okay, so I can see, and I'm only worried about my x's. Okay, so I graphed the absolute value of x minus 4. I graphed negative x squared plus 8x minus 13. Okay, and saw that these are the 2 points where they overlapped. So, and I rounded to the nearest 10th. Usually they'll be specific about where they want you to round to. If they're not, round to 2 decimal places. Okay. So if I round to the nearest 10th, I get 2.69, which rounds to 2.7, and 5.30, which stays at 5.3. Okay. So in summary, graph whenever possible and use Desmos when you can. Look for where expressions intersect, use the intersect feature if graphing on a calculator, and you might need to use a table to approximate the solution. Okay. And that is the end of lesson 5.